Welcome back again, I'm B. Today I have for you guys a new minigame in VR. This time it's a classic WhackAMole game with cute avocados. Please subscribe to my channel so you won't miss any notifications for new videos. Okay, let's check this out. This is the scene that I have set for the minigame. We have a game controller, which is a blueprint WhackAGame controller. We have a hammer, which is a pickup. And we have those cute avocados. So check this out. We can see the avocados goes up and down, and we can hit them with a hammer. Let's check first the hammer. The hammer is just a pickup. That pickup is based on the base project that I'm using for all these videos related to VR. Let me show you how to quickly create a new pickup of this type. Just a reminder. So basically, we just need to create a new C++ class. Show all classes to show everything. And look for pickup. We will select the pickup, next, and put a name. That's how you create this hammer. If I open the blueprint class, it doesn't have anything difficult over here. It has a root, which is a scene component, the base, an interactive collider to collide with the controller, a pickup snap locator, so as soon as I detect the hand detects this element, it will snap to that location. I also have a hit collider and a static mesh. Let's check quickly the code. So this is extends from pickup, and apart from all the components that comes on the pickup, I added this hit collider that I will use for the avocados. And the code is just basically that. Just create the default object, a U-box component with the name hit collider, and that's it, nothing else for the hammer. Let's check the game controller. So the game controller is this element with all of these pipes. And what we have here is different spawn points. In this case, they are 7, one for each pipe. In this blueprint class, I added these 3 elements to represent the game, and the pipes for each spawn point. I use these spawn points to spawn each avocado. Let's check the code. The code is very simple. The game controller extends from an actor. It has a root and the 6, 7 spawn points. I included this array to keep all the track of all spawn points. In the constructor, I create the root as a default object and each spawn point, and I attach them to the root. I gave different names for each one of them, and that's it. That's what we have on the blueprint. Next thing is to spawn each object to whack all those avocados and put them on the same position at the spawn point. So first thing I do in the begin play is to add its spawn point to this list. So I can go through to this list and spawn its avocado on the right spawn point. This TRA keeps things simple for me. Okay, so next thing is to spawn all of the avocados. This element over here is just the blueprint class that I'm going to spawn. And is a T subclass of object to work. That's the avocado blueprint. So the code goes like this. For each element in this list, so for each spawn point, I'm spawning the avocado or this object to work. As a transfer, I take the spawn point. I usually like to check these kind of things to make sure that nothing is going wrong. Next thing I do, if this is not null, I attach this object to the spawn point where the avocado is spawned. And as a rule, I'm using the snap to target not including scale, so the avocado will snap on that point. I don't have to give a position and a transfer. Everything will fall in the right place and in the right orientation and location. Next thing I do is set to the set position for the avocado down. So I keep a reference to the end position, which is exactly the point where this element is spawned. That will be the end position when the avocado moves up. So this will give the avocado the target position to move. And the start position is the same, 13 units down. I can use an U property to set this element, or I can use a scene component to set this more accurately, but this works. For this tutorial is more than enough. So next thing is set this element in that position, set the actor location, and I initialize the object with those positions. One thing I want to mention is decided to use pooling for this type of thing. So I have 7 elements in total. Instead of spawning its avocado every time I hit it, or every time the avocado goes down, I prefer to reuse the same element over and over again. This usually is better for performance to improve things. For prototyping it's not very important, but if you have lots of particles, for example, it's highly recommended to use pooling in these cases. It will improve things in the game. Let's go back to the blueprint game controller and check all of this code. So we have the root here, and we have its spawn point and its pipe. So basically, when I have the begin play, the avocado will snap to this location and spawn right at the bottom. Let's go now to the avocado, or the object to work that is going to be spawned in this game controller. This cute avocado is thanks to Quaternions, so make sure to check his Patreon on the description to get more low poly elements like this. So as usual, this blueprint extends from an actor. So I have a mesh, the root, the hit trigger that I will use for the hammer, an audio, so when we hit this avocado a sound will spawn or play, and some particles. These particles are not part of the class, C++ class. I basically add them to the blueprint after that. Okay, so we have the root as using component. the static mesh, U-box component with the heat trigger, and the audio. If we go to the constructor, we have those all of those sub-default objects: the scene component, the mesh, the heat trigger, and the heat audio, and all of them goes attached to the root. For the heat trigger, I added this event to detect any overlap actors. In this case, it will be the hammer. So I'm using this begin overlap element method. The code to move the avocado up and down is handled in this class. So as you saw in the game controller, I basically spawn the elements and that's it. Everything else is made in this object. For that, I'm using states. I'm using the tick to move the avocado and other actions. So I'm using states. I have the current state and the next state. And for that, I'm using an enum. The enum is defined here. So we have different states. None, which is nothing is going to happen. Idle, which means the avocado will keep in idle position for a while after the move up. The other state is go up from the start position to end position, and that time it will go up. Go down, the same, it will go from the end position to the start position again. I also included this wait to start state, which is basically as soon as you spawn the avocado, it will wait time. And finally, a reset. I have those states defined here: current state and next state. I also have this enable collision because I like to handle this myself. So I only enable the collision when the avocado is in the end position and is in idle. So the state matchings goes like this. First, spawn the avocado, and the state to wait to start is set. After a time, the avocado will go up, and it will change to idle state. And in that precise moment, I will enable the collision. That's the only time I will allow the collisions to work between the hammer and the avocado. After the idle ends, after some time, which I define in this U property, time in idle, it will go down again, and the cycle goes that way over and over again. Okay, so this begin play happens as soon as the avocado is being spawned, and the first state is known and next state is known as well. I disable the collision, and I also disable the mesh, so we won't see the avocado down. Next thing that happens after it's being spawned, I'm calling this initialize event on the game controller. That happens here with the start position and the end position. So first I spawn the avocado and then I initialize that avocado. So I keep reference to the start set position, the end set position. I usually like to keep this delta time that I'm gonna use later for on the tick. I set to 0 the current velocity for the avocado, and the first state it's going to happen is wait to start. Obviously, when this state ends, the next one will be go up. And finally, I decided to include a random for the delay when the avocado starts. So all of the avocados are going to be spawned, and all of them will start at different times. randomized. On the tick, I'm handling those current states. So first one is the wait to start. And what happens is, in this state, I'm gonna wait this delay to start, which is a random time between these two values. So I will use this current delta time, which is general for all the actions tick. And when the time reaches the delay to start, I set this to 0 again to make sure that nothing is out of control. I set again the current velocity, which is over here, but this is just in case. And I set the current state to next state. In this case, it will be go up. So that means when this state finishes, it will go up and move up. I disable the collision again, and I set the mesh, the visibility of the mesh, to true, so we can see the avocado going up. So this state is to handle the avocado going up. I'm using the current velocity and an acceleration rate. So this will start in 0 and it will accelerate. Not a constant, it's not constant, it's not linear, it's more with acceleration. So it will have a nice easy out or easy effect. This acceleration rate is a new property, so I can set this on the blueprint and set whatever I want. So the code is simple. They start in 0, then I take the current location and I update the set position with that velocity and set the actor. Then I check if this set reaches the set position, so that's the end. That means the avocado is on the target position. And that time I enable the collision. This is just to make sure that that's exactly the position. I set the current velocity again to 0 and I reset this element. And the next thing happens is the current state is gonna be idle and the next state is gonna be down. So this means as soon as it's on the target position or the end position, it will stay there for a little while. So this is the time that we can hit the avocado with a hammer. So the idle state is very simple. It's just waiting for this time in idle to happen. And the same, I use the current delta time with the delta time. When it reaches that time, it will reset and it will go to the next state. And I set the collisions to false. So as soon as the avocado starts to go down, we cannot hit it anymore. This time in idle is another new property, so I can set this on the blueprint. The go down code is similar to the go up. This case is basically the reverse. So I use again the acceleration rate and I set the current set position with that current velocity, but this time I subtract, so it will go down. And the same, I set the actor location, and when the set position reaches the start position, that means the avocado is back in the same place again. So it is ready to go up again. And I need to set the states again. So next state, it will go wait to start again. The next one will go up. I set the variables again to 0. And I set this randomized start time again with a random. So everything will be random and not repetitive, and it's a simple way to add some random elements to the game. And obviously I set the mesh to visible, not visible. Last thing for this code, a couple of things. Begin overlap. This is the code when we hit to handle if we hit with the hammer this whack object. So that's only going to happen in the idle state, and so that's why I have this check over here. The code is just check if the other actor is the type hammer pickup. So I cast the other actor to that, and if it's not null, that means we can hit it. We hit it the avocado with the hammer. So we reset the current state to reset. We disable the collision. We disable the mesh. We play the audio, and we call this blueprint event, which is a blueprint implementable event. So this will only happen on the blueprint, and there is no any implementation for the in C++, only the blueprint. Next thing is I have this timer to reset everything again. This is just an extra step after being hit. So I use a timer with this wait to reset time, which is a U property as well, and the method that is going to handle this timer. And that is defined over here in this section. So I have again a U property to define how long is going to be this wait, the timer, and the function. And needs to be U function, otherwise it won't compile. And it's basically a method to reset everything. So I clear the timer, I get the current position, and I set that to start again because everything is going to be resetted. I set that to that current position. I reset again the variables, and the current state is going to be wait to start, and the next one go up. And again I use the random delay to start. So this, as soon as we hit this one, it will start in a random time. Okay, the code for this minigame is completed. It's as simple as this. It doesn't have anything complicated, just a couple of techniques that you can apply to other games. I really like this technique to use states, because sometimes we have ifs to check these kind of things, and in the end it's very complex. So this way is more readable. And I also like to add random elements to everything because it makes things interesting. Let's check the blueprint again. So as I said, I include these hit particles. Those ones which are just stars. And I use that event on hit to activate the particles. And that's it. That's everything for this minigame. I hope you liked it. Please subscribe and like the video. You can leave me any comments or questions that you have. Thanks for watching. Bye.